So in this video, we're going to look at the idea of a functional group in an organic molecule. Now, a functional group is basically a group of atoms or an atom that can replace one or more hydrogens in a straightforward chain of a straightforward hydrocarbon molecule like this. So we can take out one or two or three hydrogens and replace them with a different group of atoms. We can call that group a functional group. Now, functional groups dictate lots of the chemical properties of a molecule. And so the chemical properties such as how they're going to react and how they're going to be soluble in different substances. So these functional groups control the chemical properties of organic molecules. So the first type of functional group that we are going to look at now are halogens. So halogens are obviously group 17 or group 7, depending on what sort of groups we're talking about. The group 17 or group 7 elements. So it means they're in the second from the right column on our periodic table. And they need one extra outer shell electron. So like hydrogen, they only want to form one covalent bond to become stable. So basically, halogens, if we have a chain like this, a regular alkane, and one hydrogen atom is substituted for an atom of a halogen. So this could be, for example, a fluoride atom, a chloride atom, a fluorine atom, a chlorine atom, a bromine atom, or an iodine atom. Then any hydrogen on this atom, on this molecule, can be replaced with one of these. And in that case, the whole molecule becomes what we call a haloalkane. And so when we're renaming this, let's say, for example, when we're looking at all of these functional groups, we'll pretend that this is the hydrogen that's getting swapped. So what we have then is, if we was to swap this hydrogen there with an atom of fluorine, then we would say that we have one fluorobutane. So if we had chlorine, it would be chloro or bromo or iodobutane. And so we just put the name of the halogen that has been substituted in front and the number of the carbon that it is on. Now, another type of functional group that we can deal with is a hydroxyl functional group. So if we have a hydroxyl functional group, this means that we are replacing one of these hydrogens with an oxygen, and then there is a hydrogen bonded to that oxygen. So that is a hydroxyl functional group. And if we were to do that to an alkane, if we substituted one hydrogen atom for a hydroxyl group like this, we would call the whole molecule an alkanol. And so the way that we name these is if we have butane, if we have an alkane, we remove the E from the name and we replace it with an OL. So for example, if we have butane, and let's say again we've put our functional group on this end carbon here, then it would become butan 1-ol. Alternatively, we could also refer to it as 1-butanol. So that's how we name our alkanols. Another functional group that we often come across is a carboxyl functional group. Now, a carboxyl functional group is slightly more complex. It requires us to remove all three hydrogens and thus can only be present on the end carbon in a carbon chain. It can't be on a middle carbon because we would only be able to replace two hydrogens. So we need to replace all three. And so if we have a carbon like this, we're replacing these three hydrogens with an oxygen like that, and then an OH like that. That is our carboxyl functional group. And so when we name it, this is obviously always on the end carbon, so we always attribute this carbon here with the number 1. And that helps us with our positioning of any other functional groups that may be on the same molecule as this carboxyl functional group. And the way that we name molecules with carboxyl functional groups is if we have butane, then we get rid of the E and we rewrite it like this. So obviously this is an acidic hydrogen, and so we have an acid when we're talking about carboxyl functional group. So we're basically just adding oic acid to our stem, our butane stem. Now the last functional group that we're going to look at now is amines, is an amine functional group. And so an amine functional group looks like this. So we replace one hydrogen with an NH2 group. And so if we were going to replace that hydrogen there, then we would call this, there are a few different ways we can write this. We can take this butane stem again and write it as butane 1. Make a little bit more room down here. We can write this as butane 1 amine. We can write it as butyl 1 amine. So this is the name of a butane alkyl group. Butyl 1 amine or 1 amino butane. So a few different ways we can write it. So usually we would write this as butane 1 amine. However, 1 amino butane can come in useful as we're about to look at. So obviously these are the way we name our things. However, there's a few of these that rely on changing the end of the name of our original alkane, and so we need to figure out how we deal with more than one functional group on one molecule. Well, basically, no matter what, if we have a carboxyl functional group, it takes preference and it gets to rename the alkane as an oic acid. So our highest priority one is a carboxyl functional group. And so if we have a carboxyl, our second priority, is our hydroxyl functional group. Our third priority is our amino group. And our fourth priority is our halogen. And so what that means is that no matter what, if we have a carboxyl functional group, we get to call it an oic acid. And that way, if we have a carboxyl functional group and a hydroxyl functional group, rather than going with butane 1-ol, we could call our atom. We say the number, so maybe 1, then we say hydroxy, and then we say butanoic acid here. So I'm going to run out of it. So then we say butanoic acid. So 1-hydroxy-butanoic acid. So we move this, rather than calling it a butanol, we get rid of the ol, we call it an acid, and we bring this hydroxy to the front. The same thing happens if we have an amine. Obviously, if we have a hydroxyl or a carboxyl functional group, we bring the amino to the front. And lastly, we have halogens. And so if we have a halogen and an amino and a hydroxyl out the front of our name, then we write the halogen first, and then the amino group second, and the hydroxyl group last. So we're going in basically the higher priority. If all of these functional groups are out the front of our name, so they're before the name of our molecule, then the highest priority gets to be last. It gets to be closest to the actual stem, this butane part. So we're going to try and piece this together and name this really, really complex looking molecule down here. Well, first of all, we'll identify all of the functional groups. So we've got halogens here. We've got 2 halogens here. We've got 2 bromine molecule atoms there. Now, if we want to look at for a hydroxyl group, we have a hydroxyl group there. We have our carboxyl functional group here, and lastly, we have our amino functional group just here. So because we've got a carboxyl functional group, we're going to call this the first carbon. And so we know that we're going to have our halogen as our first name. And an important thing that we also want to be aware of is this alkyl group here. So the way this is going to work is that we'll write it up here. We first put our alkyl group. So we have, this is the carbon number 1 because of our carboxyl group. So that means 1, 2, 3, 4, 5, 6. So we're dealing with heptane, is our longest chain 7. However, on our 6th carbon, we've got a methyl group. So we'll go 6 methyl. Next, we look for our halogens. So these are on the 4th and 5th atoms. And so we go 4, 5, di, because we've got 2. So we use di and tri before these names of our functional groups if there are more than one of them on our atom. So we'll make a bit of room here. It's going to be quite a long name. We're often not going to be dealing with things like this, but it's important to go through how we would do this. So we've got 4,5-dibromo. Now on carbon number 4, we've got an amino group. So we put 4-amino. On our 3rd carbon, we've got a hydroxyl group. 3-hydroxyl. Gonna have to make some more room here. So now we're up to our acid finally. And lastly, hydroxyl, our longest chain is 7, so we're going to have heptanoic acid. So that is our name, 6-methyl 4,5-dibromo 4-amino 3-hydroxyl heptanoic acid. It's a little bit ridiculous, but we're just going through the motions of this priority list and how we can use how we name these functional groups. Now, it's one last thing that I'm going to point out is that if we have more than one halogen, so if we have a bromine atom and a chlorine atom and an iodine atom, we do them in order. We're obviously going to have a number, then bromo, then a number, then chloro, then a number of iodo. So we're going to put them, we put these in alphabetical order if there are more than one of them. So that is how we name really complex ones. So we've got these different functional groups, and if we put them all together, this is our priority list. And so we'll go through how these functional groups can react and react with other molecules in another video.